Hello children, today I am here to teach you Chapter 4, Part 1 and 2 in your syllabus, Factors and Multiples. So we'll see what are factors and multiples and any integer, how you can find out whether it is divisible by 2, 3, 4 like that. So we'll find out more about factors and multiples. Look at this number 274. How can we find out whether the number is divisible by 2? You already know that. If it's an even number, it's divisible by 2. So we'll look at 274 is an even number. Divide by 2. 2 times 1, 2 times 3, 6, 1 remaining and then 7. So it's divisible. Take this number 358. We know that last digit is an even number. So that means this whole thing is even number. 2 times 1, 2. For 15, that's 7. For 18, that's 9. Divide this by 2. 2, 1, 3. Divide this by 2. 510. 2 times 2, 4, 1 remaining, 5, 10, 1 remaining and 5. So 255. Divide this by 2, 1 and for 12 that's 6 and 1. So all these are even numbers, so we know that it's divisible by 2. All above numbers are divided by 2 without a remainder. Without a remainder. Look at the last digit of each above numbers. What can you say? You get 0, 6, 4, 8, 2. 2, 4, 6, 8 or either 0 or even numbers. When the last digit of any large number is either 0 or an even number, it can be divided by 2 without a remainder. So remember how we identify whether the number is divisible by 2? Look at the last digit. Last digit should be either 0 or an even number. Look at these numbers. If it's divisible by 2, you can put a tick mark, and if it's not, you can put a cross. You have to look at the last digit, 4. So it's divisible by 2. 9. Not divisible. 0, yes, it is divisible. 8, even number, yes, it's divisible. 3, no, that's not an even number, it's not divisible by 2. Look at this one, 4, yes, it is divisible. 6, again, it is divisible. 1, not divisible. 0, yes, it's divisible. And 7, it's not divisible. Find whether the following numbers are divisible by 5 now. So we'll take these numbers and divide by 5. 5 times 7, 35. For 25, that's 5. So it's divisible. 5 times 8, 40. For 20, that's 4. That's also divisible. Look at this one. 5 times 1 and 3 remaining. 34, that's 6. 45, that's 9. That's also divisible. 5 times 1, 5. 1 remaining. 5 times 3, 15. And for 20, that's 4. So all these numbers are divisible by 5. So how we identify? Look at the last digit of the above numbers. They are either 5 or 0. 5, 0 here, 5, 0. They can be divisible by 5 without a remainder. So how we identify whether the number is divisible by 5? Last digit should be 0 or 5. Now put tick mark for numbers divisible by 5 without a remainder and cross mark for numbers not divisible by 5. in the cage in front of each given number. So what we do, we look at the last digit, 5. So it's divisible by 5. 0. Yes, it is divisible. 8? No, because only 0 and 5. For the last digit, the number is divisible by 5. 8? No. 7? No. 0 years. 5 years, and this one also correct. So you have to only look at the last digit. Look at this one. Find out whether the following numbers are divisible by 10 now without a remainder. Take a look at all these numbers. 360. So 10 times 330 for 60, that's 6. 580. 10 times 550 for 80, that's 8. This one, 10 times 440 for 70, that's 7. 810 here. 810 divided by 10, you get 8. And for 10, that's 1. All these are divisible by 10. Now we'll see the last digit of the above numbers is 0. Look at all the numbers. Last digit is 0. So if the last digit is 0, the number is divisible by 10. Place tick mark if they are divisible by 10 without a remainder, and place cross mark if not divided. So last digit is 0. So it's divisible by 10. Here 5 not divisible. 3 also not divisible. In this number 0 is there. It's divisible by 10. Here not. In this one, yes, 0 is there. So it's divisible by 10. 5, no. Here 0, yes, and this one also yes. Here also divisible by 10. So how we identify whether the number is divisible by 10? Look at the last digit. If it is 0, it's divisible by 10. Complete the following table. If divided without a remainder, put correct while cross mark if not divided. So look at this number, last digit 0. Divisible by 5 without a remainder. Last digit 0 or 5, it's divisible by 5. Divisible by 10? Yes, last digit is 0. That's divisible by 10. This one, 5. So 5 means divisible by 5 but not divisible by 10. 0, divisible by 5 as well as 10. Here 2. It's not divisible by 5 or 10. Here 0, divisible by 5 as well as 10. Here also 0, it's divisible by 5 and 10. Here 5 is there. It's divisible by 5 but not divisible by 10. So look at this one. If 0 or an even number is the last digit in the ones place, then that number can be divided by 2 without a remainder. If 0 or 5 is that last digit in the ones place, that number can be divided by 5 without a remainder. And if 0 is the last digit in the ones place, that number can be divided by 10 without a remainder. So we did divisible by 2, 5 and 10. Now we'll see what is the digital root of a number. Sometimes we call this is the lucky number. So look at this one. Gaura's birthday is on 11/2. That means February 2002. Find out the digital root. So how can we find out the digital root? We add all the digits. So here 1 plus 1 plus 0 plus 2 plus 2 not 2. So you have to add all digits and see what's your lucky number. 1 plus 1, 2, 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8. Till you get one digit, you have to add. So Gaura's lucky number is 8. That's called the digital root. Birthday of Gaura's grandfather is 12/11. That's November 1948. Find out the digital root of his birthday. So we'll add all the digits. 1 plus 2 plus 1 plus 1 plus 1, 9, 4, 8. So 1 plus 2, 3. 3 plus 1, 4. 4 plus 1, 5. 5 plus 1, 6. 6 plus 9, 15. 15 plus 4, 19. 19 plus 8, 27. Now you get 2-digit number. So again you have to add these 2 digits. 2 plus 7, you get 9. So Gaura's grandfather's lucky number is 9. Here we get 2 numbered figure as the answer. So they should be once again added to get the answer. So here 27 we can find out taking 2 plus 7. Find the digital root of the following numbers. So we'll add it. 2 plus 7 is 9. So lucky number is 9. 3, not 8. 8 plus 3, 11. But 11 is 2-digit number. So you have to add it again. 1 plus 1. That's 2. 5127. Add all the digits. 5 plus 1, 6. 6 plus 2, 8. 8 plus 7, 15. Now add the 2 digits. 1 plus 5, that's 6. This one, 4 plus 8, 12. 12 and 10, 22. 22 means 2 plus 2. You get 4. Here, 6 plus 7, 13. 13 plus 7, 20. And 9, 29. Now add the 2 digits. 2 plus 9, 11. Again, you have to add. 1 plus 1, 2. Till you get one digit, you have to add. 3 plus 7, 10. 18 and 18 plus 4, 22. 22 plus 5, 27. Add 2 and 7. You get 9. 488. 8 and 8, 16. 16 plus 4, 20. So add 2 and 0. You get 2. That's the digital root. 9999. So 4 9s, you get 36. Add 3 and 6, you get 9. How many 4s are there? 1, 2, 3, 4, 5, 6. 6 4s, you get 24. 2 plus 4, you get 6. This one, the 335,704. 3 plus 3, 6. 6 plus 5, 11. 11 plus 7, 18. 18 plus 4, 22. 2 plus 2, you get 4. Find whether the following numbers are divisible by 3 without a remainder. Now we'll check out these numbers. We'll divide by 3. 3 times 1, nothing for 2. For 21, that's 7. So it's divisible. 612 divide by 3. You get 2 here. Nothing there. 3 times 4, 12. 102. 3 times 3, 9. For 12, that's 4. 201. This is 3 times 6, 18. For 21, that's 7. 67. That's divisible by 3. Now we'll find out the digital root of all these numbers and see. 3, 2, 1. 5, 5 plus 1, 6. 612, 6 plus 1, 7. 7 plus 2, 9. Here 102, 1 plus 2, 3. And 201, that's 3. Now look at the digital root. When you get 369 as the digital rule, the number is divisible by 3. So you need to remember how you identify whether the number is divisible by 3. The digital root should be either 3, 6 or 9. Find out the digital root of the following numbers and find whether they are divisible by 3 without a remainder. So we'll find out the digital root. 8. We'll straight away add this. 8 plus 1, 9. 9 plus 3, 12. So 12 means 1 plus 2, you get 3. 408. 8 plus 4, 12. 2 plus 1, 3. This one, 3 plus 1, 4. 4 plus 7, 11. 11 plus 2, 13. 3 plus 1, 4. 5 plus 1, 6. 6 plus 2, 8. 8 plus 2, 10. 11, 12. So 1 plus 2, 3. 3 plus 4, 7. 7 plus 5, 12. 12 plus 7, 19 and 21. 2 plus 1 again, that's 3. 6 plus 7, 13. 13 plus 5, 18. 8 plus 1, 9. 7 plus 2, 9. 9 plus 9, 18. And 1, 19 and 24. So 2 plus 4 again, 6. Now we found out digital root. Now check whether this number is divisible by 3 without a remainder. So what's the condition? If the digital root is 369, the number is divisible by 3. So this is 3, this is divisible by 3. Here also this is divisible by 3, but 4 is not. Here 3 again, yes. Yes, 9 also possible. Here 6 also possible. So only this number is not divisible by 3. Look at these numbers. Write the numbers divisible by 3 without a remainder from the above numbers within the set of A. So what you have to do? You have to find out the digital root. 2 plus 1, 3. So that's divisible by 3. 3 plus 1, 4. It's not divisible. 4 plus 1, 5. It's not divisible. But here 5 plus 1, yes, it's divisible. 51. 6 plus 1 again not divisible. 7 plus 1, 8. Not divisible, but 81. 8 plus 1, 9. That's divisible by 3. 9 plus 1, 10. That's 1 plus 0 again 1. So that's not divisible. So only 21, 51, 81 are divisible by 3. Look at these numbers. Write the numbers divisible by 3 without a remainder from the above numbers within the set B. Again, check the digital root. 5 plus 2, 7. That's not divisible. 5 plus 1, 6. 6 plus 2, 8. Not divisible. 5 plus 2, 7. 7 plus 2, 9. That's divisible by 3. 5 plus 3, 8. 8 plus 2, 10. Not divisible. 5 plus 4, 9. 9 plus 2, 11. 11 means 1 and 1 again 2. Not divisible. Here 10, 12. 12 means 2 plus 1 again 3. That's divisible by 3. 562. 6 plus 5, 11. 11 plus 2, 13. 13 means 1 and 3. You are getting 4. 5 plus 7, 12. 12 plus 2, 14. 14 means 5. Not divisible. 5 plus 8, 13. 13 plus 2, 15. 15 means 6. That's divisible by 3. So these are the numbers divisible by 3. Identify the numbers that are divisible by 4 without a remainder. We'll take these numbers and divide by 4. 4 times 6. So that's divisible by 4. Here 4 times 1, 4. For 22 that's 5. And for 24 that's 6. That's also divisible. 4 times 8, 32. For 28, that's 7. 300. 4 times 7, 28. For 20, that's 5. That's also divisible. This one, 4 times 6, 24. For 10, that's 2. 8. And for 20, that's 5. 4 times 8, 32. Then 32, 38. For 38, you get 9, 36, remainder 2. 5 times 1, 4 times 1, 4, 1 remaining. For 10, 4 times 2, 8. For 21, that's 4 times 5, 20. And for 14, 4 times 3, 12. And remainder 2. This one divide by 4. 4 times 1, 4. For 3, nothing. For 31, that's 7. 28. So you get 30. So again 7, 28. For 20, that's 5. So these two numbers are not divisible by 4. Now look at the last 2 digits and see. We'll look at last 2 digits. So this is 24. Here also 24. 48. 0, 0. 58. 14. 0, 0. So how we identify whether the number is divisible by 4? If the final 2 digits of the above numbers are either 0, 0, 24, 48, 64, 28, 32, that means the numbers are divisible by 4. So you have to only look at the last 2 digits. So here 58 is not divisible by 4. So the whole number is not divisible. 14 also not divisible by 4. So that means 5014 is not divisible by 4. Select and write the numbers divisible by 4 without a remainder from the following numbers. So what we do? We take the last 2 digits. 75 not divisible by 4. 44, yes. So 344 is divisible by 4. Here 0, 0. If it's 0, 0 also it's divisible. 84 divisible by 4. So 1284 divisible by 4. 72, 4 times 1, 4, 32. So that's divisible by 4, 972. 55, It's not divisible by 4. But 0, 0, yes, it's divisible by 4. Here also 0, 0, it's divisible by 4. 36, yes, it is divisible by 4. So 4,536 divisible by 4. What about 58? 4 times 1, and for 18, it's not divisible by 4. So you can't write that number. Write 3 numbers beginning from 5, ending with 2 and having 4 numbers. So you can create anything. So numbers beginning from 5. So 5, but ending with 2, 4 digits. Ending with 2, write 3 numbers. So 4, having 4 numbers, 4-digit numbers. So you can put any number in between. 7, 3. 5 and 2, you can put 9 and 1. 5 and 2, 8 and 3. Another one. You are asked to write only 3 numbers. So these are the 3 numbers, starting from 5 and ending with 2. Look at this one. Write down all the numbers less than 100, divisible by 4, without a remainder, and 6 at the ones place. Last digit is 6. And the number should be less than 100. That means only 2-digit numbers you can write. How we identify whether the number is divisible by 4? The last 2 digits should be divisible by 4. So we can put 16 because that's less than 100. 16 is divisible by 4. Then 26 is not divisible. 36, yes. 46, no. 56. 56, is this divisible by 4? 1, and for 16, you get 14. So that's divisible. 66, it's not divisible. 76, check 76 and see. 76 divided by 4, 1. And here 36, that's 9. It's divisible. So 76 is okay. What else? 86. It's not divisible because 4 times 2, 86 is not divisible. 96. Divisible by 4. 4 times 2, 8. For 16, that's 4. It's divisible. So 96. So these are the numbers less than 100. Last digit is 6 and all the numbers are divisible by 4. Look at this one. Write 6 even numbers that do not divide by 4 without a remainder. Even means last digit either 0 or even number. So we'll put 0. And it's not divided by 4. So what's the condition? You can't put 0 there. What about 30? Is 30 divided by 4? No. So you can put 30 and any number. So 30, or you can put any number here. 330. It's not divisible by 4. Another one. You can put 2 as the last digit. And what about this? Can be 2. 22 should be there because it's not divisible by 4. And here we'll put any number here. 122. Then another number 8 and 18. It's not divisible by 4 and you can put any number here. 3. So you are asked to write 6 even numbers. Another even number, you can put 6. But if you put 2, 26 is not divisible by 4. And then here you can put any number, 526. 1, 2, 3, 4. Another 2. So 2 and 32 is divisible. 42, it's not divisible by 4. So put any number here. 5. Another one more. We'll put 8. And 18 is not divisible by, or we'll put 28 is divisible. 38 is not divisible by 4. So you can put any number here, 600 or any number here. It's not mentioned to write only 3-digit numbers. You can write any number that you like, but only condition is the last 2 numbers. It's not divisible by 4. Write 6 numbers with the last digit as 0 and not divisible by 3 and 4 without a remainder. So you need to be careful now. 0 is there. Last digit is 0. Not divisible by 4. That means this can be 30. Last 2 digits 30. And not divisible by 3 means the digital root cannot be 369. So here 3. So we can put 1 there. 1 plus 3, 4. Digital root is 4. So that's not divisible by 3 or 4. Another one. Put 0 for last digit. And 10. 10 is not divisible by 4. So if you put 2, it's divisible by 3. So we can put 3. 3 plus 1, 4. 4 is not divisible by, the digital root 4 means not divisible by 3. Another one, you can put any number of digits. 0. We'll put last 2 digits. 30, 40 divisible. 50, it's not divisible. So 50. Then 5 plus 1, 6. 6 plus 1, 7. Now digital root is 7, not divisible by 3, and 50, not divisible by 4. Another one. Last digit is 0. And we'll put 60, it's divisible. 70, it's not divisible because 4 times 1 for 30, it's not divisible. So 70 is the last 2 digits. Then now think about the digital root. 7 plus 1, 8. 8 plus 2, 10. So 10 is not divisible by 3. Digital root 10 is not divisible by 3. Another one, we'll write a big number, 1, 2, 3, 4. We need 2 more. 0. And 80. 80 is divisible by 4. 90. You can put 90 there. And now put numbers in front. 9 plus 1, 10. 10 plus 1, 11. 11 plus 2, 13, that's 4. Digital root is 4. So 21,190 is also possible. Another one more, 1, 2, 3, 4, 5. One more, 0. We'll put 10. Now see the digital root, 1. 5 plus 1, 6. 6 plus 2, 8. 8 plus 2, 10. 10 plus 1, 11. So 11 means digital root is 2. So not divisible by 3. So what's this number? 122,510 is also not divisible by 3 or 4. Finding a number divisible by 6 without a remainder. How we do that? We can check whether the number is divisible by 2 or 3. If it satisfies, definitely that number is divisible by 6. So we can check it's an even number. Yes, it's divisible by 2. What's the digital root? 7 plus 2, 9. 9 plus 6, 15. 15 means 6. That means it's also divisible by 3. So definitely if these two are okay, that means it's divisible by 6 as well. Look at this one, 5. Last digit is 5 means not divisible by 2. Digital root 11 plus 5, that's 16. So 6 plus 1, 7. 7 is not divisible, so definitely this is not divisible by 6. Last digit is 8, divisible by 2. Digital root 3, 3 plus 4, 7. 7 plus 8, 15. That means 6. 6 means divisible by 3. Then definitely this is divisible by 6 as well. Last digit is 4, divisible by 2. Digital root 8, 8 plus 4, 12. 12 means 3. It's divisible by 3, so definitely it's divisible by 6. Last digit is 4, divisible by 2. Now the digital root 7 plus 4 is 11. 11 plus 4, 15. That's 6. It's divisible by 3. That means divisible by 6 as well. Last digit is 5. Not divisible by 2. 1 plus 8, 9. 9 plus 5, 14. 14 means 5. It's not divisible by 3. So definitely it's not divided by 6. Last digit is 6. That's even number. Yes, it's divisible by 2. Digital root 9. 9 plus 6, 15. That's 5 plus 1, 6. It's divisible by 3. So that means it's divisible by 6 as well. If the digital root is divisible by 3, the number is divided by 3. If the number is an even number, it can be divided by 2 without a remainder. All those numbers divisible by 2 and 3 without a remainder can be divided by 6 as well. Finding a number divided by 9 without a remainder. So we did so far 2, 3, 4, 10, 5, 6. Now 9. Look at the following multiples of 9. All these multiples of 9. Take 9. So digital root is 9. 18. 1 plus 8. Digital root is 9. 2 plus 7. Digital root is 9. 36. 3 plus 6. That's 9. So take any number. 7 plus 1, 8. 8 plus 1, 9. Here 4 plus 4, 8. 8 plus 1, 9. All multiples of 9, you get the digital root 9. So that means you can look at the digital root and see whether the number is divisible by 9. 45, 4 plus 5, that's 9. 117, 7 plus 1, 8. 8 plus 1, 9. 135, 8 and 9 here. 7 plus 1, all these digital roots are 9. 10, 18, 8 plus 1, 9. So 9 is the digital root of all the above numbers. So any number whose digital index or digital root is 9, it is divided by 9. Select and write the numbers that is divisible by 6 without a remainder from the following numbers. So how you identify whether this is divisible by 6? First check whether this is an even number. This is not. So it's not divisible by 6. 690, it's an even number. Now we'll check the digital root. 9 plus 6, 15. That's 5 plus 1, 6. 6 means it's divisible by 3 as well. So 690 divisible by 2 and 3, that means divisible by 6. This one, even number, correct. Digital root. 10. 10 plus 3, 13. 13 plus 1, 14. That means 4 plus 1. That's not divisible by 3. This is an even number. Check whether this is divisible by 3. 8 plus 4, 12. 12 plus 1, 13. 13 plus 2, 15. So 5 plus 1, 6. It's divisible by 2 and 3. That means divisible by 6 as well. Check the digital root. 10, 12. 12 means it's divisible. 774, even number. Digital root. 14 plus 4, 18. 8 plus 1, 9. So that's divisible by 3 as well. 916. 10. 10 plus 6, 16. That means 7. So not divisible by 3. 4 plus 4, 8. 8 plus 1, 9. It's divisible by 3 and 2. That's divisible by 6. This one even, yes. Then digital root. 9, 10, 16. 6 plus 1, 7. So that's not divisible by 3. This one even number. Look at the digital root. 3, 3 plus 7, 10. 10 plus 2, 12. It's divisible by 3 as well as 2. So definitely divisible by 6. If a certain number is divided by another whole number without a remainder, what you call that number? That is a factor of the first number. So what are factors? If a number can be written as a multiple of two whole numbers, they are considered as factors of the first number. Take a look at 24. What are the factors? If we take 1, that's 1 times 24. So 1 and 24 both are factors. 2 is also a factor. 2 times 12. You can write the same thing as 3 times 8. 4 times 6. And 6 times 4 again you can write this way. So what are the factors of 24? 1, 2, 3, 4, 6, 8, 12, 24. So all these numbers we call, those are factors. So you can create that number by multiplying the two numbers. So those are factors. Write the set of factors of 36. 1 times 36. 2 times 18. 3 times 12. 4 times 9. 6 times 6. So what are the factors of 36? Always 1 and the number itself are factors. 2, 3, 4, 6, 9, 12, 18, 36. So these are the set of factors of 36. All numbers are there. All factors are there. Write the set of factors of 60. 1 times 60. 2 times 30. Divide by 2 and see. When you divide by 3, you get 20. Divide by 4, 1. And for 20, that's 5. 15 times 4. Divided by 5, you get 12. And here, divide by 6, you get 10. So, what are the factors of 60? Starting from 1, 1, 2, 3, 4, 5, 6 here, and then 10, 12, 15, 20, 30, and 60. So, those are the factors of 60. Now, we'll look at what are prime numbers. Take a look at 2. What are the factors of 2? 1 and 2. So, factors of 2, 1 and 2. Take 3, 1 times 3. Factors of 3, 1 times 1 and 3. What about factors of 5? 1 times 5. So, you get 1 and 5. Look at carefully what are the factors. 7 means 1 and 1 times 7. Factors of here 7. Factors of 7, you get 1 and 7. So, take a look at all the factors. 1 and the number itself. So, what are prime numbers? If a number has only 2 factors and the factors are 1 and itself, so those numbers are called prime numbers. Select and underline the number out of the following numbers divided by 9 without a remainder. So, how you identify a number is divisible by 9? The digital root should be 9. So, we'll look at 3 plus 6, 9. That means divided by 9. 7 plus 5, 12. 12 plus 6, 18. 8 plus 1, 9. 2 plus 2, 4. 4 plus 4, 8. 8 plus 1, 9. That's divisible by 9. 9 and 9, 18. 8 plus 1, 9. 2 plus 3, 5. 5 plus 7, 12. 12 plus 6, 18. That's also divisible by 9. Take a look at this one. 4 plus 5, 9. 9 plus 9, 18. That's also divisible by 9. Here also 8 plus 1, 9. This one, 8. 8 plus 8, 16. 16 plus 2, 18. 18 means 9. All the numbers are divisible by 9. This one, 10. 10 plus 8, 18. 8 plus 1, 9. 7 plus 7, 14. 14 plus 1, 15. 15 means 5 plus 1, 6 is not divisible by 9. So, all the other numbers except 177 is divisible by 9. Select and underline the numbers out of the following numbers divided by 6 and 9 without a remainder. How you identify? We have to check the digital root. And this should be an even number, because to check whether the number is divisible by 6, it should be definitely divided by 2. So, definitely out of this we can cross out this, because this is an odd number. This is an odd number, not divisible by 6. These numbers we can cross out. Now, for the other numbers, we have to check the digital root. 10. 10 plus 8, 18. It's divisible by 9 as well as 6. 6 plus 2, 8. 8 plus 1, 9. 9 is divisible by 9 as well as 3. Here 15, that means 5 plus 1, 6. It's not divisible by 9, so you can't select that. 7 plus 1, 8. 8 plus 2, 10. 10 plus 8, 18. 18 means 9. That's divisible by 9 as well as 6. This one, 7. 7 plus 8, 15. 15 means not divisible by 9. Here, 16, 20, 27. Divisible by 9 as well as 6. 384. 12. 12 plus 3, 15. 15 means 1 plus 5, not divisible by 9. Now we'll look at this question. Factors. 24 glass marbles should be packed with similar number, leaving any remainder. Write down all the ways it can be done. So you can do 1 glass marble in each 24. That means 1 packet. 2 glass marbles in each, 2 times 12. Then you get 2 packets. 3 glass marbles in each, 3 times 8. So you can make 8 packets. 4 glass marble in each, 4 times 6. And you get 6 packets. 8 glass marbles, 8 times 3. You get 3 packets. With 6 glass marbles, 6 times 4. That's 4 here. And with 12, 12 times 2, 24. So you can make 2 packets. And with 24, again 1 packet here. According to the above information, the set of numbers that can be divided by 24 without a remainder. So 1, 2, 3, 4, and 6, 12, what else? 12, 24. These are factors. Now we looked at prime numbers. Now what are composite numbers? We'll take a look at 4. What are the factors of 4? 1 into 4, 2 times 2. So factors of 4 you can write 1, 2, 4. Factors of 6, 1 times 6 or 2 times 3. So what are the factors of 6? You can write 1, 2, 3, 6. 1, 2, 3, 6. What are the factors of 8? 8 means 1 times 8. So 8 you can write 2 times 4 as well. So what are the factors of 8? You get 1, 2, 4, 8. Now take a look at all the factors here. If a certain number has more than 2 factors, it is a composite number. Prime factors, you get only 2 factors, 1 and the number itself. So composite numbers, you get more than 2 factors, then we can identify that number is a composite number. Write the set of composite numbers less than 21. So not prime numbers. So 1 you can't take. 1, just 1 factor is there. 2, 3, 4 is a composite number. 5 is a prime number. 6 is a composite number. 7 is prime. 8 is composite. 9, composite. 10, 11 is a prime number. 12 is a composite. 13 is prime. 14, 15, 16, 17 is prime, 18, 19. 19 is prime, 20 is the last number. Less than 21 means you can't write 21. So these are the composite numbers less than 21. Finding prime factors of a number. Write number 24 in every way as a product of two numbers. 1 times 24. 2 times 12. 3 times 8. 4 times 6. So what are the prime factors out of these? So write all the factors here. We can write the factors of 24 is 1, 2, 3, 4, 6, 8, 12, 24. Out of these factors, what are the prime factors? The factors are prime numbers. So what are the prime numbers there? 2, 3, that's all. So prime factors of 24 is either 2 or 3. And write all the prime factors. So you can write 2 and 3. And write 24 as a product of prime factors. How can you write down as a product of prime factors? You can take the number, divide by only the prime numbers. Take 2, you get 12. Another 2, 6. 2, 3. So 3, 1. Till you get 1, you have to divide. Now, how many times you multiply by 2? 2, 2, 2. And 1, 3. Or you can write how many 2's? 3 2's into 1, 3. So this is a product of prime factors. So 2 to the power 3 and 3. Now take 36 and write down everywhere as a product of numbers. 1 times 36. 2 times 18. 3 times 12. 4 times 9. And 6 times 6. So what are the factors of 36? You can write 1, 2, 3, 4, 6, 9, 12, 18, 36. Those are the factors. Out of the factors, what are the prime factors? 2, 3, that's all, 2 and 3. Now, product as prime factors, how can you do? You can divide by 2. 2 times 18. Again, divide by 2, 9. You have to divide by 3 now. 3 times 3 and again divide by 3, you get 1. So what are the factors? 2 times 2, 4, 4 times 3, 12, 12 times 3, 36. So here 2 times 2 times 3 times 3, or you can write 2 to the power 2 because twice are there, and 3 to the power 2. Here also twice are there. So that's the value 36 as a product of prime factors. Write all the prime numbers from 1 to 40. Starting from 2, 3, 5, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17 is prime, 18, 19, 20, 21, 22, 23, 23, 24, 25, 26, 27, 28, 29, a prime number. 30, 31 is a prime number. 32, 33, 34, 35, 36, 37 is a prime number. 38 and 39 is not, and 40. So these are the prime numbers 1 to 40. Write all the composite numbers from 1 to 30. Composite means you get more than 2 factors. 1, 2, 3, 4, 5, 6, 7 is prime, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 here, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29 and 30. 1 to 30 means you can include 30 as well. So those are composite numbers. Finding highest common factor. So we'll take the numbers 18 and 30. Now what are the factors of 18? It's 1 divisible by 2. So 2 is a factor. It's divisible by 3. 3 is a factor. 3 times 6. Then 4, 5, 6. 6 times 3. 7, 8, 9 times 2. Then 10, 11, all these. Again, finally, 18. So those are the factors of 18. What are the factors of 30? Starting from 1. Divisible by 2. It's divisible by 3. 3 times 10. 4, 5. 5 times 6. 6 also a factor. 7, 8, 9, 10 is a factor. Then 15 times 2. So 15 is a factor and 30. Now what are the common factors of 18 and 30? 1, 2, 3, 6. What else? That's all. So out of these, what's the highest one? Highest common factor of 18 and 30 is 6. That's the highest one. Now take these two, these three numbers 28, 42 and 63 and see what's the highest common factor. Factors of 28. 1. It's divisible by 2. 3. 3 times no. 3. 4. 4 times 7. 6, 7, 8, 9, 10 and 2 times 14. So 14 is a factor. 4 times 7 and then finally 28. Factors of 42. What are the factors of 42? 1. It's divisible by 2. 3. 3 times 4. 13. 3 times what? 3 times 14. 4, 5, 6. 6 times 7. So 7 is a factor. 8, 9, 10, 11. And if it's 2, you get 21. And if it's 3, 3 times 1, 3. 3 times 4, 14 is a factor. And what else? 6 times 7. And again 42. Last digit is 42. Now, what are the factors of 63? 1. It's divisible by 3. So 3 times, so 63 comes, that's the last number. 3 times 21. And what else? 63, 9 times 6. 6 and 9. Those are the factors of 63. Now, what are the common factors out of those? We'll find out common ones. 1 is common. 2 is not. 6, no. 9, 21, it's not common. So, only 1. So, what's the highest common factor of this? So, you get only 1. So, the highest common factor of 28, 42 and 63 is 1. Finding highest common factor using prime factors. So, this is another way of finding highest common factor. Find the highest common factor of 36. So, we'll find out 36 can divide by 2. 80 divide by 2, 9 divide by 3, 3 divide by 3, you get 1. 2 times 2 times 3 times 3. 45, divide and see. You can divide by 3. Divide by 3 again. And divide by 5, you get 1. 3 times 5. 54. Divide by 2. Then divide by 3. 3. 2 times 3, 3, 3. Now these are the factors, prime factors. So how we find out the highest common factor? We'll find out the common ones and multiply. What's common? 2 is not common. 3? Yes, you get 3, a common one. That's all. Another 3. Another 3 is common. So you get 3 2 times. So the highest common factor, we take 3 times 3. You get 3 common twice. So 3 times 3, so that's 9. So how we find out the highest common factor? Using this way. So you find out the prime factors separately and see what are the common ones for all the numbers, and then you multiply those. Find the highest common factor of 64, 96, 160. Divide by 2. Divide by 2 again. Divide by 2. Divide by 2. Divide by 2. And 1. So what are the factors? 2, 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. 96. Divide by 3. 32. Divide by 2. 16. Divide by 2. 8. Divide by 2. 4. Divide by 2. And again 1. So what are the factors? 1, 2, 3, 4, 5. 2, 3, 4, 5 and 3. 60. Divide by 2. Get 30. Divide by 2. 15. Divide by 3. 5. Divide by 5. You get 1. So what are the factors of 60? 2 and 2 and 3 and 5. Now, what are the common factors? We'll take what are common? 2. Another 2. Then 3 is not common, 5 is not common, only these two. So what's the highest common factor? 2 times 2, that's 4. Find the highest common factor of 16, 36, 48 and 60. We'll divide and see. 2 times 8, 2 times 4, 2 times 2, 2 times 1. So 16 is 2 4 times. 36 divided by 2, you get 80. Divide by 2 again, 9. Divide by 3, 3 divided by 3, 1. 2 times 2, 3 times 3. 48 divided by 2, 24. Divided by 2, 12. Divided by 2, 6. 3, 3, 1. So you get 1, 2, 3, 4. 2, 3, 4 and 3. 60 divided by 2, 30. Divide by 2 again, 15. Divide by 3, that's 5. Divide by 5, you get 1. 2 times 2 times 3 times 5. Now find out the highest one. What's the highest one? 2 is common. Another 2 is common. What else? That's all. So what's the highest common factor of 16, 36, 48 and 60? That's 2 times 2, 4. Now finding least common multiple. Finding the least common multiple of 4, 6, 8. What are the multiples of 4? 4 times 1, 4. 4 times 2, 8. 4 times 3, 12. 4 times 4, 16. 4 times 5, 20. 24, 28. You can write, but we'll stop here. We'll put 3 dots. That means it's continuing. Multiples of 6. 6 times 1, 6 times 2, 12. 6 times 3, 18. 6 times 4, 24. 6 times 5, 30. 36. 42. We'll put 3 dots. Multiples of 8. 8 times 1, 8. 8 times 2, 16. 24. 8 times 4, 32. 8 times 5, 40. 48, like that. It's continuing. So what are the common multiples of all these? We'll identify common multiples. What are the common ones? 20 is not there. Can you see 24? And then what else? So 48 comes here. So when you do this, 48, next you will get 48 like that. So 48 also common for all. So this is like 24, 48 like that, common ones. We need the lowest one. So least one is 24. So that's the least common multiple of 4, 6, 8. So 24 is the answer. Find the least common multiple of 4, 6, 8 from prime factors. So how can you write 4? 2 times 2. 6, 2 times 3. 8, 2 times 2 times 2. So this is how we can do. So how many 2's are there here? 2 2's. Here 2 1 and 3 1. Here 2 to the power 3 there. So we are taking different numbers with maximum power, greatest power of them. So if you take 2's, maximum is 2 to the power 3. And then you get 3 here. So that's the least common multiple. Now, what's 2 to the power 3? That's 8 times 3, you get 24. So, previous one also we got 24 as the least common multiple. And there's another way of doing that. So, how you do that way? So, here we will try it out. You can write down the numbers at once and try to divide by prime numbers so that you get ones. 2 times 2, 4. 6 divided by 2, you get 3. 8 divided by 2, 4. Now you can divide by 2. This is 1. 3 you can't divide, so you write down the number as it is. This is 4, so you can divide by 2. Now there's another 2, so you can divide by 2. 1 you can write as it is. 3 you can't divide, write as it is, and this becomes 1. Now 3 is there, you need to divide this by 3, so you get all ones. Till you get ones, you can divide. So from this also you can find out the lowest common multiple. So 2 times 2, 4, 4 times 2, 8, 8 times 3, 24. So that way is easier to find out the lowest common multiple. Find the least common multiple dividing method of the numbers 4, 6, 8. So here, that's what I did before. So what are the numbers we got? 2, 2, 2, 3. So we get 2, 2, 2, 3. So 2 times 2, 4, 4 times 2, 8, 8 times 3, 24 as the least common multiple. So here divide by prime numbers. So here 2 also possible, 3, 5, 7 like that. Least common multiple of 4, 6, 8 is 24. So the answer you get as the least common multiple should be eligible for dividing without a remainder by each number given. Find the least common multiple of 72, 96, 108. So we'll use the factor method first. 72 divided by 2, 36 divided by 2, you get 18 and 9. Now you can divide by 3. So what are the factors of 72? 1, 2, 3 and 2 3s. 2 to the power 3, 3 squared. 96. We'll do 96 divided by 2. 48 divided by 2. Divide by 2 again till you get 1. 1, 2, 3, 4, 5. And 1, 3. 2 to the power 5 and 1, 3. 108. You need to divide by 3 till you get 1. 2 2s and 3 3s. 2 2s and 3 3s. Now we take the highest power with different numbers. When you consider 2, 2 to the power 5 is the maximum. When you take 3, 3 to the power 3 is the maximum. So that's the least common multiple. 2 to the power 5, 32. 3 to the power 3, 3 times 3 times 3, 27. Now when you multiply these two, What do you get? 32 into 27. 20 and 7. 21 plus 1, 22. When you add it, 964. So what's the least common multiple of 72, 96, 108 is 964. Find least common multiple of 64, 96 and 128 now. Divide by 2. 32. Divide by 2 again, 16. Divide by 2 here, 8, 4, 2 and 1. So how many 2's? 1, 2, 3, 4, 5, 6. 2 to the power 6. 96. 48. Divide by 2, 24. Divide by 2, 12, 6, 3, 1. 1, 2, 3, 4, 5. 2 to the power 5 and 3. 168 is not 128, 168. 2, 8, 4. 42. 21, 7 and 1. So 2 to the power 3 and 3 and 7. Now when you take different numbers, when you take 2, the maximum power is 2 to the power 6. If you take 3, that's 1, power 1 and 7. 2 to the power 6 is 64. 3 times 7, 21. So 64 times 21, what's the answer? Add it together. 1344 is the lowest or least common multiple. Find least common multiple of 14, 28, 42 by applying dividing method. So you write the numbers at once and divide. 2 times 7, 2 times 14, 2 times 24. Again you can divide by 2, but 7 you can't divide, so you write as it is. 7, here 12. Again you can divide by 2, you get 6. Again divide by 2, you get 3. Now you can divide by 3. And finally by 7 till you get 1. So what's the least common multiple? You multiply all these numbers. 2 times 2 times 2, 3, 4 and 3 and 7. 2 times 2, 4, 4 times 2, 8, 8 times 2, 16 times 21. What's 16 times 21? 20 and 1 here. And 16, you get 336. That's the least common multiple. Look at this question. The bells A in every 20 minutes, B in every 30 minutes and C in every 40 minutes respectively rings. If all 3 bells were ringing at the same time at 8 a.m., when will all 3 bells be rung once again? So if you take multiples of 20, just see, you get 20, 20 and 20, 40. Then 60, 80, 80 plus 20, 100, 100 plus 20, 120, like that, 140. If you take every 30 minutes it's ringing, then multiples of 30. 30, 60, 60 plus 30, 90, 90 plus 30, 120, 120 plus 30, 150, 150 plus 30, 180. So like that. And if it's 40 minutes interval, what are the multiples of 40? 40, 80. 80 plus 40, 120. Add 40, 160, 200, like that. Now, what's the lowest common one? Look at these values and see what's the lowest common value. 120 is common and the lowest one. So that means after 120 minutes, it will ring again. So 120 minutes means how many hours? Divide by 60, you get 2 hours. So what's the time? Again, the bell is ringing. 8 for the first time and 8 plus 2, 10 a.m. So again, the bell will ring at 10 a.m. So this is one way of solving this problem. Or you can do using factors. 20, how can you write? 2 times 10. 10 again 2 and 5. 30, how can you write? 2 times 3, 6, 6 times 5. 40, 2 times 20, again 2 times 2. 10, 2 times 2, 8, 8 times 5. So 40. Those are the factors. So how you find out the lowest one? When you take least common multiple of 20, 30, 40, this is 2 to the power 2 and 5. Here 2, 3, 5. Here 2 to the power 3 and 5. So when you take power 2, 2 to the power 3 is the maximum. 3 to the power 1 is the maximum and 5 to the power 1. 2 to the power 3 is 8. 8 times 3, 24. 24 times 5, 120. So least common multiple also 120. So which one is easy? This way is easier than finding multiples. So we'll find using least common multiple, finding factors and take the highest factor. Now we'll look at exercise in your textbook. Exercise 4.1. Without dividing, select the numbers which are divisible by 9. How we identify? Digital root. If the digital root is 9, that means divisible by 9. 5 plus 4, 9. So 504 is divisible by 9. 6 plus 5, 11. 11 plus 2, 13. 13 means you can't. 5 plus 6, 11. 11 plus 7, 18. That means yes, it's divisible by 9. 6 plus 5, 11. 11 plus 8, 19. That's not possible. 2, 2 plus 4, 6. 6 plus 3, 9. That's possible. 1 plus 3, 4. 4 plus 5, 9. 9 plus 1, 10. That's not possible. 2 plus 7, 9. 9 plus 1, 10. 10 plus 9, 19. That's not possible. And the last one, 4 plus 5, 9. 9 plus 3, 12. 12 plus 6, 18. 18 means, yes, it is divisible by 9 because the digital root is 9. Look at question number 2. Without dividing, select and write down the numbers which are divisible by 3. So what's the condition? We find out the digital root. If it is 369, the number is divisible by 3. So we'll look at the digital root. 8, 1. 8 plus 1, 9. So 9 means divisible. So you can select 81. 102. 1 plus 0 plus 2. You get 3. That's also divisible by 3. 164. 1 plus 6 plus 4. 7 plus 4. 11. 11 means again 1 plus 1. That's 2. Not divisible. So you can't select that. 189. 10, 18. That means 1 plus 8, 9. So that's divisible by 3. 189. 352. 352. 8, 8 plus 2, 10. That means 1 plus 0, that's 1. So you can't select 352. 372. 372. 9, 9 plus 3, 12. 12 means 1 plus 2. You get 3. That means okay. 372. 466. 466. 12. 12 plus 4. 16. 1 plus 6. That's 7. So you can't take 466. 756. 7, 5, 6. 11. 11 plus 7. 18. 1 plus 8. 9. That's divisible by 3. So 756 is also okay. 951. 9, 5, 1. 15. 15 means 1 plus 5. 6. That's also possible. So 951 also divisible by 3. Last one. 1 plus 0 plus 2 plus 9. 10, 12. 12 means 2 plus 1, 3. That's also divisible by 3. So 1029 is divisible by 3. So these are the numbers that are divisible by 3. Question number 3. 3 divides the number 6, 5 something such as 2 digits suitable for the empty space. So what's the condition? The digital root should be 3, 6 or 9. What's 6 plus 5? 11. 11 means 1 plus 1, that's 2. So you need one more to get the digital root 3. So you can put 1 here. So 651, you get digital root 3. Then another one. If this is 6 also, it's divisible by 3. How you get 6? What's the next number you need to add? This is 2, 3, 4, 5, 6. 4-digit number you have to add. So what's the other number? 6, 5, 4. Check. 11. 11 plus 4. 15 means 1 plus 5. You get 6 as a digital root. So that's possible. So either 1 or 4 you can put. You can check like that till you get 9 also possible. 4, 5, 6, another 3. You can put 7 also. Then 6 plus 5, 11. 11 plus 7, 18. That means 9. That's also possible. 1, 4 and what's the other number? 7. 6 plus 3. So that's 7. Question number 4. pencils were brought to be distributed among Nimal's friends on his birthday party. The number of pencils was less than 150, but close to it. Nimal observed that each friend could be given 9 pencils. What is the maximum number of pencils that may have been brought? So from this we identify the number should be divisible by 9, and as well as it is less than 150. So what's the condition to identify whether it is divisible by 9? The digital root should be equal to 9. Now we'll check with first the number less than 150 means 149, and see what's the digital root? 1 plus 4 plus 9. You get 13 plus 1, 14. Again 1 plus 4, that's 5. We'll take another number to see the pattern. 148. 1 plus 4 plus 8. 13. That means 1 plus 3. You get 4. So likewise, now you need to get digital root 9. What are the possibilities? You are getting the next number 3, 2, 1, 0. 0 means that's divisible by 9. So till you get this number, you have to find out. So 148 here. So this becomes 147, 146, 145 and 144. So we'll check 144. What's the digital root of 144? 1 plus 4 plus 4. You get 9. Digital root 9, and the number is less than 150. So what is the number? Number is 144 pencils. Question number 5. The following quantities of items were brought to make gift packs to be given to the winners of a competition. 131 exercise books, 130 pencils, 128 platinums and 131 ballpoint pens. If each gift pack should contain 3 units of each item, write down the minimum extra amount needed from each item. So that means these numbers should be divisible by 3. So we'll take the first one, exercise book. Exercise books. 131. What's the digital root? 1 plus 3 plus 1. 4, 4 plus 1, 5. How you check whether the number is divisible by 3? The digital root should be 3, 6, 9. So to get 6 here, you need one more exercise book. So need one more exercise book. To get digital root 6. Now we'll look at pencils. Pencils 130. Then 130 pencils means 1 plus 3 plus 0. 3 plus 1, 4. Digital root is 4. What should be the digital root? To see the number is divisible by 6, you need 2 more. So to get the number divisible by 3, you need 2 more pencils. So here you need 2 more pencils there. Now we'll look at the next one, 128 platinum pens. 128 platinum pens. What's the digital root of this? 1 plus 2 plus 8. 10, 10 plus 1, 11. That means 1 plus 1, you get 2. So you need digital root 3. So you need 1 more platinum. So you need 1 more. Now what's the other one? We did platinums, now 131 ballpoint pens. 131 ballpoint pens. So what's the digital root there? 1 plus 3 plus 1, 4, 4 plus 1, 5. To get 6, you need 1 more ballpoint pen. So those are the items that need extra to get a number divisible by 3. Exercise 4.2. From the following, select and write down the numbers which are divisible by 6, which are divisible by 4. So we'll do the first part. Divisible by 6. So what's the condition? It should be an even number because it's divisible by 2 then. If the digital root is 369, it's divisible by 3. Then definitely it's divisible by 6. So here we can cross out this one, that's odd number, this one, those 3 because those are odd numbers not divisible by 2. Now we'll take the digital root. 162. 1 plus 6 plus 2. 9. So that means it's divisible by 2 as well as 3. So this is correct. 912. 9 plus 1 plus 2. 12. 12 means 2 plus 1, 3. That's also correct. 966. 9 plus 6 plus 6. 9 plus 6, 15. 15 plus 6, 21. 2 plus 1, 3. That's also possible. 2118. 2 plus 1 plus 1 plus 8. 12, that's 2 plus 1, 3. That's also possible. 2472. 2 plus 4, 6. 6 plus 7, 13. 13 plus 2, 15. 15 means 6. So that's also possible. 3024. 3 plus 0 plus 2 plus 4. 4 plus 2, 6. 6 plus 3, 9. So that's also divisible by 3 and 2. 3308. 3 plus 3 plus 0 plus 8. 11. 11 plus 3. 14. 14 means 1 plus 4. That's 5. Not divisible. 3332. 9, 9 plus 2, 11. That means 2. Not divisible. 4,800 is 4 plus 8. 12. 12 means 1 plus 2, 3. That means it's divisible by 3. So these are the numbers divisible by 2 and 3. Therefore, it's divisible by 6. Now we'll take part 2. Now we want to check whether this is divisible by 4. How we identify whether this is divisible by 4? You have to take the last 2 digits. 62. Is it divisible by 4? 4 times 1, 4. For 22, that's not divisible. So you can't take that. 87. It's not divisible by 4. 12. Yes, it's divisible by 4. So 912 is divisible by 4. 66. Last 2 digits you have to check. 4 times 1, 4. 26, it's not divisible. This one, 18. Not divisible by 4. 23. Not divisible by 4. 72. 2 times 4 times 1, 4. 32, 4 times 8. That's divisible by 4. So 2, 4, 7, 2 is divisible by 4. 41 again, not divisible by 4. 24. Yes, it is divisible by 4. 4 times 6. So 3024 is also divisible by 4. 08. Yes, divisible by 4. 3, 3, not 8. 32. Yes, it's divisible by 4. 4,800. Yes, when you get 0, it's divisible by 4. So the other number divisible by 4 is 4,800. So these numbers are divisible by 4. Question number 2. Write the following numbers in the appropriate column of the table given below. A number may be written in both column 1 and 2, 1 and 3. So you need to check numbers of which 4 is a factor. That means divisible by 4. And here reason, numbers of which 6 is a factor. And give the reason. So what's the reason to identify it's a factor of 4? Last two digits should be divisible by 4. That's the condition for divisibility of 4. What about 6? What's the reason? Reason is it should be an even number. It should be an even number and the digital root should be 3, 6, 9. If it satisfies, we can say this is divisible by 6. Now we'll check each one. 348. Last two digits 48. So divisible by 4. Now check whether it's divisible by 6. It's an even number. What's the digital root? 8 plus 4, 12. 12 plus 3? 12 plus 3? 15. 15 means 1 plus 5, 6. So digital root is there. So you can write this number again here. 496. 96, is it divisible by 4? 4 times 2. Yes, it is divisible by 4. What about the digital root? 9 plus 6? 15. 15 plus 4? 19. So it's not divisible by 3. 288. Yes, it is divisible by 4. What about divisible by 3? Even number, okay. But what's the digital root? 8 and 8, 16. 16 plus 2, 18. 18 means 1 plus 8, 9. That's okay. So that's divisible by 3 as well. So definitely it is divisible by 6. 414. It's not divisible by, last 2 digits not divisible by 4. What's the digital root? 4 plus 4, 8. 8 plus 1, 9. And also an even number. It's divisible by 6. 1024. It's divisible by it's divisible by 4 because last 2 digits 24 divisible by 4. Digital root 4 plus 2, 6. 6 plus 1, 7. It's not divisible by 3. So then it's not divisible by 6 as well. This one 72. Yes. It's divisible by 4. 4 times 1, 4. 32, that's 8. So 1272. Then digital root 7 plus 2, 9. 9 plus 2, 11. 11 plus 1, 12. 2 plus 1, 3. So that's divisible by 6 as well. 306 not divisible by 4 because last 2 digit is not divisible by 4. Digital root 6 plus 3, 9. So that means divisible by 6. Then we'll do the next one there. So the other 2 numbers, 200, other 3 numbers, 258. 58 not divisible by 4. So you can't write it there. Digital root 8 plus 2, 10. 10 plus 5, 15. 15 means 1 plus 5, 6. Yes, it is divisible by 6. So 258. So you can write down the same reason that we did before. 1008. Last 2 digits 8. That's divisible by 4. So that is here. Digital root 9. 9 is divisible by 6 as 9 means divisible by 3. So definitely divisible by 6 as well. 0, 0 there, last 2 digits. That means divisible by 4. Digital root 6 plus 7, 13. 3 plus 1, 4. That's not divisible by 3. The number 6 to something and then 6 is divisible by both 4 and 6. Find the suitable digit for the empty space. What's the condition? Satisfy for 4. This should be, the last 2 digits should be divide by 4. This one, 6 means, divisible by 6 means this should be an even number and the digital root should be 369. Now it's easy to first find the digital root here. 6 plus 2 plus 6 here. 12. 12 plus 2, 14. 14 means 1 plus 4. You get 5. You need to get digital root 6 or what's the other one? 9 possible. When you take now, you need 1 more to get 6. So if we put 1 here, definitely it's divisible by 4 as well because 16 is divisible by 4. Can we find out another digit? You need 3, not 3, 4 to get 9. 46 Is it divided by 4? You can't put 4 there. So only possibility is 6216. Question number 4. A drill team arranges themselves in the following manner. On one occasion, they form lines consisting of 3 members each, and on another occasion, line consisting of 4 members. They also make circles of 9 members each. If the drill team must have more than 250 members, more than 250 members, use the divisibility rule to find the minimum number of members that could be in the team. So that means the number should be divided by 3, divided by 4 and divided by 9 without a remainder. So how we identify without a remainder? Here digital root should be 9. Here also possible. How you get 4 divided by 4? Last 2 digits should be divisible by 4. So we check last 2 digits. Now we'll take more than 250. So 2, 5 is there. We'll check up to 259. 2 plus 5, you get 7. Now you need another 2 to that. So if this is 2, you get 252. But now check whether last 2 digits divisible by 4. 4 times 1 and 4 times 3. You can divide that by 4 as well. So digital root 9. So what's the number? It can be 252. And it says minimum number. You can find several numbers more than that. So minimum number is 252. Question number 5. Determine whether 126 is divisible by 2, 3, 4, 5, 6, 9 and 10. 126. It's an even number. Can divided by 2. How we identify it for 3? Digital root. 1 plus 2 plus 6. 9. So that's okay. So that means divided by 3 as well. Next one. Last 2 digits. These 2 digits not divided by 4. So not divided by 4. 5. How we identify 5? Here last digit should be either 0 or 5. So not divided by 5. 6. How we identify whether it's divided by 6? Even number. Digital root should be 3, 6, 9. Digital root is 9. So that means definitely it's divided by 6 without a remainder. How we identify it is divided by 9? Digital root is 9. So that's correct. You can divide by 9. Is it divisible by 10? No. Last digit should be 0. So this is not divided by 10. So this is the end of part 1 in your textbook. So what's the divisibility rule? If 2 divides the ones place digit of a whole number, then that number is divisible by 2. Basically, that means an even number. If the digital root of a whole number is divisible by 3, then the number is divisible by 3. So 369. If the last two digits of a whole number consisting of 2 or more digits is divisible by 4, then the whole number is divisible by 4. How we identify whether it's divisible by 5? The last digit, ones place digit should be 0 or 5. If a whole number is divisible by both 2 and 3, then it is divisible by 6. If the digital root of a whole number is 9, then that number is divided by 9. If ones place digit of a whole number is 0, then the number is divisible by 10. So remember all these rules, then you can identify whether any number is divisible by these numbers. Now exercise 4.3, factorize. So how we find out the factors? We'll take the first one. You can divide and find the factors. 2 times 7 and 2 times 5. 3 times 2, 3 times 5. Then 5 times 5. Now we can see what are the factors. 1 with 150. First and the last number always a factor. It's divisible by 2. 2 times 75. Then 3 times 50. And what else? 5 times 30. And 6 times 25. And what else? 10, 15. You can get 15, 10. We'll do 10. 10 times 15. So these are the factors of 150. So when you ask to factorize, you can find out what are the possible products. Now we'll take 204. What are the factors? You can divide and see. Divide by 2, divide by 2 again, divide by 3 and 17. So I can write 204 as 1 times 204. It's divisible by 2. So I can write 2 times 102. Then 3 times 6, 18. For 24, 3 times 8, 68. It's divisible by 4. 4 times 5 and 1, 51. Then it's divisible by 6. 6 times 3, 18. For 24, 6 times 4. What else? 12. 2 times 2, 4. 4 times 3, 12. 12 times 17. Or 17 times 12. What else? Then what about these two? 17 times 2, 34. 17 times 3, 51. So all these are, you have already taken. 4 times 3, 12. 12 also there. So those are the factors of 204. 165. You can divide by 3. Divide by 5 and 11. So you can write 165 as 1 times 165. Then 3 times 55. Then 5 times 33. And what else? 11 times 15, or 15 times 11. Here again, when you combine, you get all the other numbers. So those are the factors of 165. 284 can divide by 2. Again, so 2 times 7, 1. So 71 is a prime number, so you can divide by 71, that's 1. So what are the factors? 284. 1 times 284. Then 2 times 142. Then 4 times 71. And here, what else? When you multiply these two, you get 142, and here 142. So that's all. 4. That's all. Those are the factors of 284. Write down the 10 factors of 770 below 100. 770. We can divide by 2. And you can divide by 5. 35, again 7. Divide by 7 and you get 11 and 1. So what are the factors of 770? Less than 100. You can write 1, 2, then 5, 7, 11. What else? Then 5 times 2, 10. Yeah, first I'll write 10 and then 11. 5 times 2, 10. 7 times 2, 14. Then 7 times 5, 35. Then 55. 11 times 5. What else? 7 times 11, 77. Do we need more? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You need 10 factors. So those are the 10 factors less than 100. Write 5 multiples of 36. 36. 36 times 2, 72. 36 times 3, 108. 36 times 4, 144. 4 times 6, 24. 4 times 3, 12, plus 2, 14. Then 5. 5 times 6, 30. 3 there. 5 times 3, 15, plus 3, 18. So those are the 5 multiples of 36. 5 multiples of 112. So you are adding 112. So starting from 112. Multiplied by 2. 224. Multiplied by 3. 336. Multiplied by 4. Multiplied by 5. 560. 5 times 2, 10. 1 remaining. 5 times 1, 5, plus 1, 6. And 5 times 1, 5. Write 5 multiples of 53 below 500. So first number is 53. Multiply by 2. Multiply by 3. Multiply by 4. Again, 4 times 3, 12, 1 remaining. 4 times 5, 20, 21. 5 times this, 5 times 3, 15, 1 remaining. 5 times 5, 25 plus 1, 26. 2, 3, 4, 5. So those numbers are below 500. Look at this question. 180 chairs in an examination hall have to be arranged such that each row has an equal number of chairs. If the minimum number of chairs that should be in a row is 10 and the maximum that could be in a row is 15, find how many possible ways there are to arrange the chairs. So 180 chairs. So check whether this number is divisible by 2, 3 like that. So here we'll start from, this is 10, so the next number is 11. Now look at 180 and see what are the factors of 180. Divide by 2, divide by 2, and divide by 3, and divide by 5. So what are the factors? So we can't take less than 10. So 180 we can write as, if it's 10, 10 with 18. So that's one possibility to arrange the chairs. Then 12, 3, 2, 2. 12 with 15. Then what else? 12 with 15 and one more, 9, 18. 3 times 3, 9. 9 times 2, 18 with 10. We did that. Another possibility, 15. We took it. We need to get less than 15. 18 you can't because 18 there. That's all. Those are the possibilities. Can we get one more? 2 times 2, 4. 4 times 3, 12. 4 times 9. 4 times 9, 36. So that's more than that. So those are the only possibilities. So here 12 times 15, or you can write as 15 times 12. So these are the rows, the minimum number of chairs that should be in a row. In a row, it can be 10, 12 or 15 chairs. Example number 1, write 63 as a product of its prime factors. So what you do? You divide and see. 21, 7 and 1. So how can you write 63? 3 times 3 times 7. Or you can rewrite as 3 squared into 7. Exercise 4.4, find the prime factors of each of the following numbers. 81. You can divide by 3. 27. Divide by 3. Divide by 3 again. Divide by 3. So you are only dividing by prime numbers. So 81 you can write 3, 3, 3, 3, 4 times or 3 to the power 4. 84. How can you divide? Divide by 2. Divide by 2 again. Divide by 3. I can write 2 times 2 times 3 times 7. Or 2 to the power 2, 3 and 7. 96. You can divide by 2. Divide by 2 again. Divide by 2 again. Again 2. 2 and 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 and 1, 3. So you can write as 2 to the power 1, 2, 3, 5 into 3. Those are the prime factors. Express each of the following numbers as a product of its prime factors. 12. Divisible by 2 and you get 3 here. So 2 times 2 times 3. 15. We can divide by 3 and 5. So 3 times 5. 16. Can divide by 2. 2 again. 2 again and 2. 2 times 2 times 2 times 2. 18. You can divide by 2 and 3 and 3. So 2 times 3 and 3. So those are the prime factors. 20. Divide by 2, divide by 2 and 5. 2 times 2 times 5. 28. Divide by 2, divide by 2 again and 7. 2 times 2 times 7. Take 59. It's not divisible by any other number, just 1 and itself. So that's a prime number. So you can't write factors there. So 1 and 59. So prime number, because it's prime number, only 1 and itself are factors. 65. Divisible by 5 and 13. So 5 times 13. So you are asked to write in prime factors 5 and 13, both are prime factors. 77. 7 with 11. 7 times 11. 91. You can divide by 7 and 13. So 7 into 13. Exercise 4.5. Find 6 factors of each of the following numbers by considering their prime factors. It's divisible by 2. Again 2 and 5. So you need 6 factors, each of the following numbers, by considering their prime factors. So you need prime, not only prime factors, any 6 factors. So 1 is definitely a factor. 2. Then you get 4 and 5. What else? 10 and 5 times 2, 10, 4 times 5 we did, and 20 times 1, that's 20. 6 factors are there. 42, you can divide by 2, divide by 3 and 7. So 1 is a factor, 2, 3, 7. And then you can do multiply, 6 is also a factor. And 2 times 7, 14 is a factor. 1, 2, 3, 4, 5, 6. You can write more. 21, 42, any number. There only you are asked to write 6 factors. 70, divide by 2, divide by 5 and 7. So 1 is a factor, 2, 5, 7. Then 10, 2 times 5. Then what is 3 times 5, or not 3 times 5, 5 times 7, 35 or 70. 1 and last number always are factors. 84, divisible by 2. Divisible by 2 again. So 3 and 7. Now what are the factors? 1 is a factor. 2, 3, 7. And 2 times 2, 4. 2 times 3, 6. Likewise, you can write any number. 4 times 3, 12. Then 21. Any number, but you need only 6 factors. 66, divisible by 2, 3 and 11. So 1, 2, 3, 11. Then 6 is a factor. What else? 22 is a factor. Then 3 times 11, 33 is a factor, 66. So you can write any 6. 99, divide by 3, 3 and 11. So 1, 3. Then 9, 11. What else? 11 times 3, 33. And 9 times 11, 99. 6 factors are there. Example number 1. Find the highest common factor of 72, 108. We'll use 3 methods. First one, write down separate factors. So 72. How can you write 72? Divide and see. You get 3 and 3. So 2 into 2 into 2 into 3 into 3. Factors of 72 you can write like that. What are the factors of 108? You can divide and see. 9, 3, 3 again. So I can write 2 twice, 3 thrice. What's the highest common factor? So highest common factor, you can take the common ones out. 1, 2 and 3 here. Another 3. So what's the highest common factor? It's CF. 2 times 2 times 3 times 3. 2 times 2, 4. 4 times 3, 12. 12 times 3, 36. So that's the highest common factor. This is one method. We'll take another method. Now we'll look at another method. So what are the two numbers? 72 and 108. 72 and 108. We'll find out all the factors of 72. 1. Then it's divisible by 2. When we have factors, it's easy. 9, 3 times 3, 1. So 2, 1, 2, 3. Then 4, 6. What else? 9, 8. So we'll put 8 first. 9. 2 times 3, 6. 6 times 2, 12. What else? Then 6 times 3, 18. Also possible. 8 times 9, 12. And then 2 times 2, 4. 4 times 2, 8. 8 times 3. 8 times 3, 24. 24 times 3, 72. So we can write down all the factors of 72. Now we'll try to write down all the factors of 108. First we'll divide and see. So what are the factors? 1, 2, 3. Then 2 times 2, 4. Then 2 times 3, 6. Then 3 times 3, 9. What else? 12. 2 times 2, 4. 4 times 3, 12 is a factor. Then 3 times 2, 6. 6 times 3, 18 is a factor. Then 2 times 2, 4. 4 times 3, 12. 12 times 3, 12 times 3, 30. 6 is also a factor. And 108 is the other one. No? 3 times 3, 9. 9 times 3, 27 is also a factor. This way, 3 times 3, 9. 9 times 3, 27. 27 times 2, 54. And then 108. Now, when you take all the factors, what are common? 1, 2, 3, 4, 6, 9, 12, 18. And here, this is also divisible by 36. We forgot to write down 36 times 2. So 36 also common. 72 and 100. Other numbers are not common. Out of these common numbers, what's the highest common factor? Out of these, the highest one is 36. So that's the second method. Now we'll take another method. So we can write 72 and 108 in a row and find out the common factors. We can divide both the numbers by 2. Again by 2. Now this one you can divide both the numbers by 3. Again by 3. Now we can't divide because 2 and 3 there are no common factors. Till you get these common factors and then you can multiply these common ones. 2 times 2 times 3 times 3. 9 times 2, 18. 18 times 2, 36. So, highest common factor is 36. So, we did 3 ways to find out the highest common factor. Example number 2. 3 types of items were brought in the following quantities to be offered at an almsgiving. 30 cakes of soap, 24 tubes of toothpaste, 18 bottles of ointment. 30, 24 and 18. Parcels were made such that each contained all 3 items. Every parcel had the same number of items of a particular type. What is the maximum number of parcels that can be made accordingly? Write down the quantity of each item in a single parcel. So what you have to find out? The highest common factor of 30, 24 and 18. So what's the easiest way to do? We can write down separately and see the common ones. 30, how can you write? You can divide by 2, divide by 3 and 5. 2 times 3 times 5. 24. You can divide by 2 and divide by 2 again, 2 again and 3. So 2 times 2 times 2 times 3. Then 18, how can you divide? Divide by 2 and 3. 2 times 3 times 3. Now, what are the common ones? 2, 3. That's all. So that means highest common factor is 6. That means you can make 6 parcels. So 6 parcels are there. So how many you can put in each parcel? 30 divided by 6. So you can put in one parcel. If it's one parcel, what are the things? 6. 30 divided by 6, 5 cakes of soap. Divide by 6. 6 times 4, 24. So 6 times 4. 4, what's that? Toothpaste. And 6 you divide by this one, 18 divided by 6, you get 3. 3 bottles of ointment. 3 bottles of ointment. So those are the things you can include in one parcel and you can make 6 parcels like that. Exercise 4.6. Fill in the blanks to obtain the highest common factor by writing down all factors of the given numbers. Factors of 8. 1, 2, 4 and 8. Factors of 12. 1 divided by 2, divided by 3, 4 and 6 and 12. Factors common to 8 and 12. 1, 2 common. What else? 4. And what's the highest common factor out of all these three factors, common factors? 4 is the highest one. Part 2, 54, written as a product of its prime factors. So it's easy. First, divide and see. 27 divide by 3 and divide by 3. So you can write 2 times, 3 times, 3 threes. Then what about 90? You can divide and see. 45 and divide by 3, get 15, divide by 3 again, 5, divide by 5, you get 1. 2 times 3 twice and 5. And 72, how can you write 72? Divide by 2, divide by 2 again, 2 and 3 and 1. So 2, 3 times and 3 twice. Now, the highest common factor of all three numbers, how can we find out? We can use the common one, 2. And here 3. And another 3. Can you see another 3 there? Another 3 common. So what's the highest common factor? 2 times 3, 6, 6 times 3, 18. So highest common factor of all three numbers is 18. Find the highest common factor of each pair of numbers by writing down all their factors. So you need to write down all factors and find out the highest one. 12. What are the factors? 1, 2, 3, 4, 6. What else? Then 12. 15. What are the factors? 1, 3, 5 and 15. Now, out of these, what's the highest one? Highest one, 3. 3 is the highest common factor. Next one, 24. 24, how can you write? You can divide by 1, 2. Then 3, 4. What else? 6. 6 times 2, 12. And 6 times 3, 18. 6 times 4, 24. Do we get another one? 4 times 3, 12. 4 times 2, 8. 6 times 4. So that's all. 24. What about 30? 1, 2, 3. It's not divisible by 4. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 2 times 3, 6. 6 times 5, 30. Do we get 15? 15 and 30. Now see the highest one. What's the highest common one? 6 is the highest common one. That's all. So highest common factor is 6. 60, 72. So we can find out all factors of 60. 1, 2, and 3. It's divisible by 4 as well. 4, 5, 6. What else? 7, no. 8, 9, 10. Yes, 10 is a factor. 12. What else? 12 times 5. 13, 14, 15 is a factor. 15 times 4. Then 30 and 60. Factors of 72. 1, 2, 3. If you can't figure out, it's easy to do this way and find out. Okay, so 2, 3. Then 4. 6. What else? 8. You can multiply and see what are the other factors. 8, 9. 9 times 2, 18 is a factor. But before that, 4. 4 times 3, 12. What else? 6. 6 times 2, 12. 9. 9 times 2, 18. Then 4. 4 times 3, 12. 12 times 2, 24. 36. 36 times 2. And 72. Now, what's the common one and the highest? Highest common factor. Look at carefully and see what's the highest one. 24, not that. 18, 12. 12 is there. That's the highest one, no? So that's the highest common factor. So HCF is 12. This is not easy. This way is the hardest one to find out the all factors and then find the highest one. It's easy to find out taking separate factors. 4 and 5. 4, what are the factors? 1, 2 and 4. 5, 1 and 5. So what's the highest one? That's 1. Highest common factor is 1 here. 72, we did that before. We'll do 96. Divide by 2. Divide by 2 again. Divide by 2. 2 again. And finally with 3. So what are the factors of 96? 1, 2, 3, 4, 6, then 8. What else? 3, 4, 5, 6, 8, 12. 24. 3 times 2, 6. 6 times 2, 12. 12 times 2, 24. 24 times 2, 48. 96. Did we miss anything? 32. We missed that. 32. Here, 16. We missed that. And 16 times 3, it's 48. It's there. Now see from 72. This and this, what's the highest common factor? 24. 24 is there. 72. 32 is not there. So 24 here and 24 here. So highest common factor is 24 there. Now we'll do the last part. 54 and 35. So 54, divide and see. 2 times 2, 4, 7. And then you get 9, 3, 3. So what are the factors of 54? 1, 2, 3. And then 2 times 3, 6. 9. Then 9 times 2, 18. What else? 3 times 3, 9. 9 times 3, 27. And then 54 times 1. Check again. 6, 9 we wrote. 9 times 2, 18. Yeah. And 35, what are the factors of 35? 1. And it's divisible by 5, 7 and 35. Only few factors are there. So what's the highest one out of these? 1, 5 is not there, 7 not there, 35. So what's the highest common factor for these two? That's only 1. So highest common factor is 1. Look at question number 3. Find the highest common factor of each pair of numbers by writing each number as a product of its prime factors. So this is the easiest way to find out the highest common factor. So 24, you divide and see. You get 2 times 6. Again divide by 2. So you can write 2 times 2 times 2 times 3. 36, how can you write? 2 times 18, 9, 3 times 3. 2 times 2 times 3 times 3. So what's the common one? 2, 2, 3. So what's the highest common factor? 2 times 2 times 3. You get 4 times 3, 12. 45. 3 times 50. 3 times 5 and 5. So what are the prime factors of 45? 3, 3 and 5. 54. You can divide by 2. You can divide by 3 and another 3. Finally from 3 again. 2 times 3 times 3 times 3. Now see the common factors. 3 is common. Another 3 is common. That's all. So highest common factor is 3 times 3. That's 9. 32, 48. 32, we know that. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. 48. 2, then you get 24. Again divide by 2, 12. Divide by 2, 6. Divide by 2 again, that's 3. You get 3. So what are the common factors? 2, 2, 2, 2. So 2 4 times. So highest common factor is 2 times 2 times 2 times 2. That's 16. 48. So 48 we have already done. We can take that one. 2 4s. You get 2 4 times. And then 3. Now we'll take 72. Divide by 2, you get 36. 36 divided by 2, 18. 18 divided by 2, 9. 9 you can write 3 and 3. Now what are the common factors? 2, another 2. 2 again, and 1, 3. So what's the highest common factor? 2 times 2, 4, 4 times 2, 8, 8 times 3, 24. 18 and 36. 18, how can you write? 2. That's 9. 3 and 3. 36. Divide by 2, you get 18. 18 divided by 2 again, 9. 9 is 3 times 3. So what's the highest common factor? You get 2 and 3 and another 3. So 2 times 3, 6, 6 times 3, 18. So highest common factor is 18. Find the highest common factor by any method you like. So which one is the easiest? Using separate factors. That's the easiest way to find out highest common factor. 18 you can write 2 times 3 times 3. 12, 6, 6 you can write 2 times 3. 15, 3 times 5. Now find out the common ones. 3. So highest common factor is 3. 12, 18, 24. 2. 6 is 2 times 3. 18 divided by 2, 9. 9 is 3 times 3. 24 divided by 2, 12. 12 divided by 2, 6. 6 you can write 2 and 3. So what's the highest common factor here? 2 is common. 3 is common. 2 times 3, that's 6. 24, 32, 48. Divide by 2, 12. Divide by 2, 6. Divide by 2 and 3. 32, we know that 2 5 times. 48 divided by 2, you get 24. Divide by 2, you get 12. Divide by 2, you get 6, 2 and 3. So what's the highest common factor? 2, another 2, another 2. 3 is not common. So 2 times 2 times 2, that's 8. This one, 18, 27, 36. 2 times 9. 9 is 3 times 3. 27, 3 times. 36 divided by 2, 18. Divided by 2, 9. 9 is 3 times 3. What's the highest common factor? 1, 3 is common. Another 3 is common here. That's all. 3 times 3. That's 9. Question number 5. A basket contains 96 apples and another basket contains 60 oranges. 96 apples and 60 oranges. If these fruits are to be packed into bags such that there is an equal number of apples in every bag and an equal number of oranges too in every bag, and no fruits remain after they are packed into the bags, what is the maximum number of such bags that can be prepared? So that means highest common factor of 96 and 60. So we'll find out. So 96 divided by 2, you get 48. Divide by 2 again, 24. Divide by 2 again, 12. Divide by 2, you get 6. That means 2 times 3. 60 divided by 2, 30. 30 divided by 2, 15. 15 divided by 3, you get 5. Then divide by 5, you get 60. So what's the highest common factor of these two numbers? 2, 2, 3. 2, 2, 3. 4 times 3, 12. So that means we can make 12 bags. So in one bag, how many apples? 96 divided by 12. What's the number? 8. 8 apples. And 60 divided by 12, you get 5. 5 oranges you can keep. 5 oranges. So how many bags? 12 bags, each 8 apples and 5 oranges. Example number 1, find the lowest common multiple of 8, 6 and 16. How we find out the lowest common multiple? We'll first find out all factors and see which one is the lowest. 8. How can you write? 2 times 2 times 2. I can write 2 to the power 3. 6. 2 times 3. 2 to the power 1 and 3 to the power 1. 16. 2 4 times. So when you are finding lowest common multiple, you take the different numbers with maximum power. When you take 4, when you take 2, 2 to the power 4 is the maximum. What else? 3 only once. So the lowest common multiple is 2 to the power 4 is 16 times 3, 48. So that's 48. Now we'll use another method, second method. We can write 8, 6, 16 in a row and divide. Divide by 2. Divide by 2 again. Here 3 you can't divide, you write as it is. Divide by 2 again. And divide by 2. Till you get 1, you have to divide. Divide by 3. So you get 1, 1, 1. Now we multiply all these numbers. That's the lowest common multiple. 2 times 1, 2, 3, 4. And 3. So you get the same answer. 16 times 3. 48 as the lowest common multiple. Example number 2. 2 bells ring at interval of 6 minutes and 8 minutes respectively. If they both ring together at 8 a.m., what time they will ring together again? So we'll take all multiples of 6 first. 6, 12, 18, 24, 30, 36, 6 times 6, 6 times 7, 42. What else? 6 times 7, 6 times 8, 48, like that. Those are multiples of 6. Multiples of 8. 8, 16, 24. 8 times 4, 32. 8 times 5, 40. So like that. Now, what's the common one? When you look at carefully, can you see 24 is the next common one? So that means after 24 minutes, it will ring again. So 24 minutes, that means what's the time? 8:24. So it will ring at 8:24 a.m. Now same thing, second method. So you need to find out the lowest common multiple of 6 and 8. So how we find out the lowest common multiple of 6 and 8? We write down like this, divide by 2, divide by 2 again, here 2 again, and 3. Till you get 1, you divide and multiply these two. So lowest common multiple is 2 times 2 times 2 times 3. 8 times 3, 24. This is in minutes. So 8 plus 24 minutes means 8:24. It will ring again. Exercise 4.7. Find the lowest common multiple of each of the following triples of numbers. We can take at once and find out the lowest common multiple. Divide by 2. Divide by 2 again. Divide by 2. Divide by 3. And finally again by 3. So what's the lowest common multiple? 2 times 2, 4. 4 times 2, 8. 8 times 3, 24. 24 times 3. 3 times 4, 12. 1 remaining. 3 times 2, 6 plus 1, 72. Now this one, 18, 8, 14 and 28. Divide by 2. Divide by 2 again. Divide by 2 and divide by 7. Till you get 1, you have to divide. So what's the lowest common multiple? 2 times 2 times 2, 8. 8 times 7. You get 56 is the lowest common multiple. 20, 30, 40. You can divide by 2. Divide by 2 again. Divide by 2. Divide by 3. And finally divide by 5. You get all ones. So what's the lowest common multiple? 2 times 2, 4. 4 times 2, 8. 5 times 3, 15. So 8 times 15. 8 times 5, 40. 8 times 1, 8 plus 4, 12. So 120. 9, 12, 27. You can divide by 2. Divide by 2 again. Now you can divide by 3. 3 again and 3 again. So what's the lowest common multiple? 2 times 2, 4. 4 times 3, 12. 3 times 3, 9. 12 times 9, 108. 2, 3, 5. You can divide by 2. Divide by 3. And divide by 5. So what's the lowest common multiple? 2 times 3 times 5. 6 times 5, 30. 36. 54, 24. Divide by 2, 18. Divide by 2, 7. Divide by 2 here, 12. Again divide by 2. Can divide by 2 again. Now divide by 3. Divide by 3 again. And 3 again. Till you get 1. Now what's the lowest common multiple? 2 times 2, 4. 4 times 2, 8. 8 times 3, 24. And 3 times 3, 9. 9 times 4, 36. 3 remaining. 9 times 2, 18. Plus 3, 21. So the lowest common multiple is 216. Question number 2. At a military function, 3 cannons are fired at intervals of 12 seconds, 16 seconds and 18 seconds respectively. If the 3 cannons are fired together initially, after how many seconds will they all be fired together again? So how many seconds? So that means we need to find out the lowest common multiple in seconds. So we'll find out the lowest common multiple of 12, 16 and 18. Divide by 2. Divide by 2 again. Divide by 2. Divide by 2. Divide by 3 and 3 again. So what's the lowest common multiple? 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. And 3 times 3, 9. 9 times 16. 9 times 6, 54. 5 remaining. 9 times 1, 9 plus 5, that's 14. So after again 144 seconds, again you can see the 3 cannons at the same time. Miscellaneous exercise. Without dividing, determine whether the number 35,343 is divisible by 3. How we find out? Digital root. 3 plus 5, 8. 8 plus 3, 11. 11 plus 4, 15. 15 plus 3, 18. 18 means 1 plus 8, 9. So digital root is 9. So that's divisible by 3. Last 2 digits not divisible by 4. So that means not divisible by 4. What about 6? How we identify whether it's divisible by 6? It should be an even number. So this is not an even number. So not divisible by 6. And 9, digital root is 9. So that's divisible by 9 as well. Fill in the blanks. The highest common factor of 2 and 3. What's the highest common factor? There's no common factor. So we write only 1. The lowest common factor of 4 and 12. What's the lowest common multiple of 4 and 12? You can find out. 3 times 2, 6. 6 times 2, 12. That's the highest number. The highest common factor of 2 prime numbers is So like this. Always when you get two prime factors, highest common factor is always 1. The lowest common multiple of 2, 3 and 5. 2, 3 again and 5. 2 times 3, 6. 6 times 5, 30. Find the highest common factor and lowest common multiple of 12, 42 and 75. So we'll use the factor method because for highest common factor, anyway we need the factors. 12, 2 times 6, 6 you get 2 times 3. 42, divide by 2, 21, 3 and 7. Divide by 3, you get 25. That's 5 and 5. Highest common factor, we just see what's highest. Common ones only. 3. Lowest common multiple. We can write down 2 twice and 3 ones here. Here 2 ones, 3 ones and 7 ones. Here you get 3 ones and 5 twice. So for lowest common multiple, you take different numbers with the highest power. 2. When you take 2 to the power, 2 is the highest. 3, just 3 to the power 1. 5, 5 to the power 2 is the highest. And you get 7 to the power 1. Now multiply. 4, 4 times 3, 12. 5 times 5, 25 and 7. So 12 times 7, we'll multiply these two. 84 times 25. What's 84 times 25? 20 and 5. 0, 8, 16. 5 times 4, 20. 5 times 8, 40. Plus 2, 42. $2,100 is the lowest common multiple. It is proposed to distribute books among 45 students in a class, such that each student receives no less than 5 books and no more than 10 books. If this is 5 books, if this is 5 books, how many books altogether? 45 into 5. 225. And it is no more than 10 books. If it's 10, how many books are there? 450. So the number of books should be in between 225 and 450. But that should be divisible by 45. Because there are 45 students. So what's the lowest number? It can be 225. Then add 45 to that. You get 10, 7, 270. Then add 45 again. 350. 45 again. 360. Another 45. 405. Another 45, 450. So the number of books can be in between 225 and 450. You can get any number here. So we covered the second part of chapter 4 in this lesson. And what did we do? We identify what are prime numbers and highest common factor, lowest common multiple. So we explained several methods to identify highest common factor and the lowest common multiple. So you can choose the easiest one to solve problems.